Hey, this is Tim here. I hope you're doing well. This is my. I'm going to show you how to model a plastic fork. This is the first lesson we do in the advanced Solidworks class. I like to pull out a plastic fork and give it to the students with the calipers, and they laugh because they think it's going to be really easy. But there's a little bit of skill in modeling a plastic fork, or I'd like to think. Now I'm not a plastic designer. Um, uh, I've only done a little bit of work with plastics. Um, Definitely the majority of engineering that gets done around my area is metal and CNC and aluminium and machining. I'm sure if you're, I don't know, I'm guessing if you're in Hong Kong or in China, you're definitely going to be spending a bit more time designing with plastics, which is kind of a different beast compared to designing with metal. But anyway, I'm going to show you how I would model this plastic fork. It's not going to be perfect, um, but it might do the job. Don't put it in any mold and mold it because you might have some major problems. Anyway, I'm going to show you how I would do it step by step. What are you going to need? You're going to need a plastic fork. Excuse me. Excuse me now. You're going to need a plastic fork. Some forks, believe it or not, are really lame. Some are quite. There's some. I don't know if I want to admit this, but I've looked at plastic forks over the years as I've done this project, and we had some quite simple ones in the college, and I'm after digging this one out of a drawer in my house. So this is quite a nice one because it has like reinforcing ribs and a nice good handle and what sort of. So what are we going to try and model? I'm going to model the main shape. We have some sort of a shell. We have ribs. It is a fork. It's not a spoon, so you're going to need these cutouts. There's a lot of little fillets everywhere, and then it looks like you have these little cutouts. So the first thing you're going to do, that I always do, is I just take a pencil and my fork, and I just trace it because my drawing skills are a bit rough. So you can just trace the fork. It doesn't have to be perfect. We're just trying to get the outline of it. And I'm not even going to bother getting that front section. I'm just going to just draw that in. So it looks something like that. Terrible. Alright, and then we're going to draw the side profile. Be nice if it kind of corresponded with this view here. Alright? Something like that. Lovely. Okay. So you have your sketch, and what do we need? We need some measurements at certain areas. I'm going to draw this with a loft. Now, the nice thing about modeling a plastic fork is you kind of go over, if you've ever had, it's a good, I think, in my opinion, it's a good lofting exercise. So I need a dimension there. I see I didn't draw this too well. I need a dimension there. I need a dimension there. Where else? I need a dimension. What I'm going to do is I'm going to add fillets on this end. So I need a dimension at the end, and you'll notice that we're going to kind of approximate that this lines up with here, and I need this dimension here. I need that dimension, and then I need all these lengths. Okay. Now, that's it. I think that's all I need. I'm using dial calipers because I always lose the batteries. So you have your main jaws here, your exterior jaws here, your interior jaws there. You can measure the depths of things, whatever the distance is from that to there is the same as from there to there. Now, so let's start. This is in inches, so I'm just going to go here like this. What is this? I'm getting 0.681. Alright, 0.681 inch. Look, you could probably do this with if you're kind of accurate with a cheap ruler you had in the house. So don't worry if you don't have a calipers. It's good practice, or you can just take my measurements. Now what do we have here? 0.322. Okay. So let me just zero my calipers again. I messed it up there. There we go. Let's try that again. .10. Look at that. 1.1. I love it. 1.1. Just get. You don't want to bend the. Come on now. Are you going to focus in on what I'm trying to do here? Is it going to focus? Is it on autofocus? Yeah, it should be on autofocus. Why is it doing that? Let's give it a second. Is it going to wake up? Do I need to click this button here? There you go. Alright, that's good. Okay. Sorry about that. Now what is this? This is 0.833. 0.833. Okay. And then from the top, now how can we measure this? Something like that. That'll do. We'll just get an approximation. 0.69. Now, we can always change it later. 0.690. Damn it, anyway, do I have a measuring tape? It might not be long enough. Alright, let's go from there. What I'm going to do is I'm just going to mark it. I can score it with the sharp ends of the jaw. Okay, that'll work. Now what do we have from there down? It's 4.37. 4.37. Now what's that? 5.5. That'll do the job. 5.5 inches from there to there, and I don't have a long enough caliper, so I'll just go from. Did I score where that was? I did. Is that 5.5? I'm just going to check it again. God, that's a bit bigger. Let's get to 5.5. And then I'll get the last bit. One point seven, 1.75 will do the job. Now, is that all the dimensions I need? Yeah, that's it. That should be good. I'm going to need a little bit in here for these tongs and the thickness and things. This will do the job for the first. I wonder, is it worth doing it now while I have the camera set up? I think it is. Okay. I'm gonna just hold that tight, and I'm just gonna measure from end to end. And we'll just make it 0.2. We'll do the job. 0.20. And then we'll get what are the length of the tongs, if that's even the right word. From there to the very end, we make it 1.47. 1.47. And then this little diameter here down the end is going to be, we get the interior jaws going, is going to be it's 0.09 I'm getting. 0.09 inches. Alright, and then the thickness, we need the thickness of the fork, the depth of the fork. It's 0.17, we're going to make it 0.175. 0.175. Now is it the same all the way along? Yeah, we'll assume that the thickness is the same apart from the tip, which will make it a little bit smaller. We'll make it like 50 thousandths here. We'll worry about that later. So just 50 thousandths there. And then the thickness, that's 50 thousandths thick. The shell thickness 0.05 an inch. So that's good enough. Let's get down to business. Put the calipers away. I'm going to close you down. Okay. And right, let's. So hopefully, I have it written down. So hopefully you guys have it written down as well. Right, let's open up Solidworks, and we're going to start off with a loft. So I'll get a new part. I checked it in inches. I'm going to turn on the right plane, which is there, and I'm going to get some. How many planes do I want? 1, 2, 3. Okay. Now I'll flip it. Now what's this one? This is 4.37. .37, 5.5. Why is that a lot bigger than that? This one here was 4.37. This one here was 5.5 from there. Let's try that again. We'll go from there, and then we'll get another one. We'll flip it. What are we going to type in here now? 5.5 plus 1.75. 7.25. It's a good fork. Right. Now what I'm going to do is just to get it. I never do this, but I'm going to do it because just for good habit. Can I rename that? I haven't. How do I rename that? I'm just going to put in 5.5. Can I rename that? I'm going to rename that 0. 5.5. We'll rename this one how long? 4. This is 5.5. This guy is 4.37. This lad's 5.5, and this guy is 7.25. When I have lots of planes in a part, I will label them. You know, if when I'm doing like a loft probably, or some sort of complicated part, I will label the planes. Alright, first thing I'm going to do is I'm going to turn these off, and let's create a sketch on here. Let's try that again. Okay, and what is it going to be? We're going to draw a rectangle. I'm going to draw a corner rectangle like so. The top of the fork is going to be the origin, like that, the origin here, midpoint. The thickness of the fork we said was 0.175, and this is 0.688. 0.81. Okay. Now you're probably saying to yourself, well, the bottom of that fork is round. We're going to add fillets later, I hope. Okay, we got that. Let's turn this on. And we're going to turn this sketch off. And I'll turn this plane off. .31. We're going to draw a rectangle, midpoint. This is the neck of the fork, so it's a little bit smaller. It was 0.322, and this is 0.175. Alright. Okay, we have one, so it's going to be like that. Is that right, or am I? Let's have a look. Okay, that's good stuff. Now watch this. I can fix what I want to do. That's sketch number 2 is on the right one. Sketch number 4 is on the wrong plane. Watch this. I right click here. I go edit sketch plane. I go, we don't want it on that bloody plane. We want it on another plane, which is this one here. And I go okay. So no worries. So there's the first plane. There's the second plane. The third plane's a little bit more complicated. Alright, we'll turn this one off. I'll turn this one off. Okay, we can leave those sketches there, they're fine. Let's go to 5.5 and let's create a sketch on there. And I'm going to do this in 3D. Now, we know the thickness is 0.175. I know the width is 1.1. I'm going to put this, I'm going to get a center line going, and I'm going to make this and you, come on, we'll make it symmetrical. This has to drop down though. Now we said from the very bottom to the very top is 0.69, so watch this. I can go from there, even though this guy's not on, oh, let me do it. Yeah, we can go to the origin. Yeah, lovely. 0.69, so it comes down a bit. Okay, now we got that, and right, so we have that the last sketch is the point of the fork, which is on here. So I'm just going to create a sketch on there, and that's fine. I'll draw a rectangle. I'll make him and this guy. Come on now. Sometimes to select origin you have to be looking at it at 2D. .175. And what is the width? Nah. Oh, we said the tip of the fork we'd give it a little bit pointier. And what's this? This is 0.833. Hopefully you've written down these measurements, and what I would do is I would think about where I'm getting them from, and it's going to make a little bit more sense. Alright, now let's have a look and see if we can do this at one continuous loft. If not, I might have to split it up into two. So we'll go loft. I'm not going to use a guide curve in this example. Yeah, okay. Okay. I'm going to do this. We'll just do one at a time. We have that. That's good. That looks realistic. That's one loft, and then we'll do another loft. Right. I feel like I should kind of explain why I'm doing it as two separate lofts. Let's try one again. That's not a good explanation. Let's just do one loft. great, thanks. Lovely. Thank you. Now this is interesting. I don't know why the Loft is trying to fit all of these sketches, these cross sections into one curve. Sometimes whenever I'm doing a loft like this, if I can't get one loft to work, I'll just break it up. It's okay. So let's try that. Yeah, there was no way that was going to work. These things are called control points, and they can add twist to your free form. What I can do is I can grab them and move them around, and that's not great. Okay, now watch this. This loft has 3 sketches. It has this plane, that one there, and that one there. Now, you know the fork doesn't take a strong bend. The fork comes off straight and then starts to bend around. So how do we do that? We go into start and end constraints. This one was the starting sketch, so that's the start constraint. This guy is the end one. Okay, now the start one, if you click on normal to profile, you can see there that this is a little bit it's okay. This isn't great. It's closer, but what I want to do is I want to make this plane come back a little bit. So it's not too bad. I'm gonna this plane here, no, this plane here, I'm gonna pull it back a little bit. I'm gonna make that 4 and see does that improve things. My Solidworks has crashed. Well, it better not crash, but it's thinking about what it's trying to do. So let's give it a second. I'm not doing all this again. There's no way. This is why you save it every 5 minutes. Come on, don't be like that. Yeah, we're back. So I got control over it, thank God. Alright, let's make this 4 and let's rebuild it. Yeah, that's not too bad. I'm kind of happy with that. Okay. Right, it's time to save it. I will call this Solidworks Fork Project. Alright. So we got that. That looks it's not too bad. This is a little bit wide here, but anyway, look, it's good enough. Alright, we got that loft in. The next thing I want to do is I want to get, we're going to fillet this corner, those 2 corners. Let's make a 0.35. Right. Looks like a child's or baby's fork, but it'll do the job. We'll turn off these sketches. Now we got that. Next thing I'm going to do is I'm going to create. No, let's do the shell. I don't know if I want to see if I can add a draft on this. There is a little bit of a draft. Let's see if this is going to work or it's going to be a disaster. Before we do that, let's do the draft. While we were doing this in class, we were having problems with it. Let me even see if I can get it to work. So it's going the wrong way. That's okay. That's better than we had. Let's see, can I change the direction of the draft? pretty good actually. I'm going to do it on the other side to see what it looks like as well. Is it going to do it on both sides? We could even, that's what I mean by a draft. It's a little bit more on the fork. If that's 10, what? Let's make it 10 degrees. That actually looks really good now. We're getting somewhere. What do I mean by a draft? This is not, if you look at any plastic fork, this line here is not perpendicular to this line here. This is coming out of a mold, so it needs a draft angle. This is what that angle is for, is to allow it come out of a mold. Okay, so that looks actually pretty good. It's looking a bit closer. Part of me wants to change. I'm going to just save this here and maybe change that length and put it back the way it was. We make it 4.37. Yeah, that's not looking too bad, and the draft angle looks good. Alright, I'm happy with that. Right, let's add the fillet. Oh yeah, fillet's good. Let's go for the shell now. $50,000. Okay, we get it. Okay, why do we use a shell in plastics? Why? Whenever you have anything made out of plastic, it needs to be uniform thickness. You do not want this to be fully solid. It would be a waste of plastic, and it would lose some strength. So you use it all over the time. But we also have this bit of an issue here with the front of this shell. I feel like if we try and take that face out as well, that might help. No. It'll be okay. We'll cut it out. I feel like I want to make that smaller. Alright, that's not looking too bad. We have that. We have the shell. What's next? Let's take the cutouts of the tongs. Then we're going to add the fillets, and then we're going to add the ribs. Right. Let's create a sketch on this face here. And right. Let's put in some circles. Alright. From there down to there, we said, I'm hitting the shift key as I'm doing that, I said it was 1.47. Let's make all these equal. Let's put a center line in. I'm kind of I did this in class with 16 people. What day is today now? Today is Saturday. I did it on Thursday and it was a disaster. Nothing worked. So I'm kind of learning from my mistakes. Let's put a diameter of 0.09. Right, I need another measurement. I have the calipers in my hand. We need to go from one center of the circle to another one. What am I getting here? I'm getting 0.52. Any of you who are serious about getting into Solidworks, you need a calipers. You can buy them at Harbour Freight. You can buy them on eBay for about $10. If you're going to be doing this serious, you might want to get a Japanese made calipers. They make the best ones. I can't remember the name of the company that makes them. Let's have a look. I don't know how to pronounce it. Mitutoyo. Anyway, that's the best one. They're good. They're like Starlet are good. They're expensive. This is what you want to do. Let's see how much a pair of these cost. You want 6-inch calipers? They're about $100. Okay. But you're not going to have any problems with them. Cheap calipers that are bought in, they'll be okay. They'll probably fall apart after about a year and a half. Alright, if you buy them Harbour Freight, you know, they're okay. You probably should just start with a cheap pair first. Um, Now what do we say? This is 0.2. Seems a bit big. Alright, I wonder if I sure, I may as well just I'll mirror that one over anyway, that's for sure. I'll mirror all of this. That's happy enough. Alright, let's make this symmetric. Alright, we have that. We'll trim these lads here. And we'll cut it. We'll go through all. And we have that. Not too bad, I like it. And what I'm going to do is I'm going to use a face fillet. Let's throw on, it's a bit too big. We'll make it, let's try 50 thousandths. Too big. 20 thousandths. Lovely. That's it. Beautiful, look at that now. Alright, what are we missing here? We have that. Let's worry about those reinforcements. Okay. How do we put those in? We need a plane right there. We're going to go plane. I'm going to click one face and another face. Worry about just getting one rib in. If you can get one rib in, you can always mirror it. Okay. Now what are we going to do? I'm going to click this. Let's create a sketch. I'm going to click. We'll click that face and we'll convert entities. Nope. What about this? Is this going to work? Let's try creating a sketch on this here, and I'm going to click that face and go convert entities, and it gives us lovely look at that. Right, and what it looks like is it in this part here, it looks like there's a line that goes from there to there, and look, I'm just eyeballing it, and then we're going to trim that bit of it away. This comes down maybe just a little bit more. Let's put a fillet on that. You're just going to eyeball that, okay? We'll extrude. I'm going to go mid-plane. Let's make this 50 thousandths. And we got one rib in. Let's turn off that plane. Is that right? Yeah, it looks about right. Look, I've seen a lot of forks. This rib will come back down. It will connect up with there, but the fork I have, it just goes down to there. There's our mirror, our center plane. Let's mirror it over to the other side. It's not going to do it for me. It's going to be a pain. What happens if I go geometry pattern? Will that work? Lovely job. Don't ask me what that means. I don't know. I just know that if I get a zero thickness error, and over the last 10 years of using Solidworks, it works. Okay, I don't know what geometry pattern means, but it seems to help whenever you're trying to pattern something or mirror something. If it's being a pain, you may as well click that button and see how it works. That's it. What's next? I'm going to put in a load of fillets. um, you're going to, on a plastic fork, you're going to have fillets all over the place. Now, why is that not lining up there like that? Let's try that again. There you go, good lad. Hey, what's up?
What are you doing?
Making a video.
Do you want to go hang out with Janet and Jim?
Janet and Jim, right now. Did they come around to the house?
She texted me.
Um,
Come on. Just for a little bit. We're not going to stay long.
right this second?
Like in 20, 30 minutes?
That's fine, yeah, 20 minutes.
Okay.
She doesn't know that I'm recording this, but I don't really care. Alright, yeah, I'm just using a face there, I'm getting lazy. Yeah, you're gonna have fillets all over the place. It's gonna drive it nuts. Yeah, I'm after crashing Solidworks. Let's see what that looks like. What's the last thing we have? I have some, on my fork I have a couple of patterns here on this face. I can always just create a sketch there on the center, and it looks like a couple of little triangles will do it. I'll do a linear sketch pattern. Go through all both, and I could do the same down the other side. Look, that's it. I'm getting lazy now. You know, you could write your name on the fork, you could do whatever you want, but how many features is that? We got 2 lofts, we have the draft, then the fillets down the end, then the shell, then a cutouts, then more fillets, the boss for the rib, another mirror on the other side. Yeah, but that's it. Look, that's your plastic fork. That's it done there, and I'm happy enough with that. So give it a lash, and for your homework, I want a couple of views of the fork. I'd like a rendering of it, or an isometric. Put it on 11 by 17 and upload it to Canvas. So I hope you're doing well. Take care.